Good morning, my name is Teresa Palominos-Rizzo. Today I'm going to present one of the articles carried out during my doctoral research at the University of Costa Rica. The title is Temporal Dynamics of Soil Erosion in Coffee in Llano Brenes, Costa Rica. Water erosion is a natural phenomenon often accelerated by human activity, and it is an environmental problem that facilitates the degradation of soil and the transfer of sediment to other areas. The objective of this study was to quantify the surface runoff and the soil erosion rate at the plot scale under natural precipitation events in an empty soil in a shaded coffee plantation, and determine the temporal dynamics and the influence of the main factors associated with this process. The study was developed in Llano Brenes, Alajuela, Costa Rica. 9 plots were installed in May 2017, and the data was collected between May 2018 and November 2019. Each plot had a runoff meter and a container for collecting sediment samples. 3 time-domain reflectometry sensors were installed for measurements of surface soil moisture content. The data analysis was carried out on a monthly, annual, inter-event, and intra-event scale. On the intra-event scale, the infiltration model of Diskin and Nazimov was applied. Regarding the result, the total annual runoff depth was 91 millimeters in 2018 and 103 millimeters in 2019. In 2018, the soil loss was 1,612 grams per square meters, and in 2019, it was 1,692 grams per square meters. This is a moderate erosion according to the Food and Agriculture Organization. In general terms, the highest value of soil loss were obtained in October of each year, despite the fact that May was the month with the highest rainfall. The main reason is that soil moisture increased during the rainy season, causing the soil to become saturated faster and generating more runoff and sediment. In the inter-event analysis, the correlation between runoff and soil loss was highly significant. Both runoff and soil loss were found to be highly correlated with precipitation and maximum average rainfall intensity. However, another moderately correlated variable was soil moisture content. This shows us that it is an important variable to explain the generation of runoff and soil loss. In the intra-event analysis, the variables used in the model were the maximum infiltration capacity when the content of surface storage water in the soil layer is very low, the minimum infiltration capacity when the surface water content of the soil is at the saturation point, the maximum water storage capacity in the soil, and the storage conditions based on soil moisture. 11 events were randomly selected for calibration, totally 69 millimeters per hour of observed runoff and 72 millimeters per hour of estimated runoff. For validation, 10 events were selected that add both the observed and estimated runoff of 66 millimeters per hour. Hyetograms were made to plot the observed and estimated runoff, in addition the precipitation and infiltration capacity. At this scale of analysis, in some events the model underestimates runoff at 0. However, the infiltration model meets an acceptable estimate of the total runoff values. In conclusion, the precipitation depth, intensities, and initial surface moisture content of the soil played an important role in the generation of runoff and soil loss. The Diskin and Nazimov model used in the intra-event analysis helped demonstrate the dynamics of humidity and its physical properties of infiltration capacity in the soil had a high participation in the generation of runoff for the total of rainy events. Thank you very much for your attention.